In this lesson, we talk about the slope of parallel and perpendicular lines. Let's begin by talking about parallel lines. Parallel lines are two or more lines in a plane that never intersect. Here is a graph of two parallel lines. Two non-vertical lines in a plane are parallel if they have the same slope and different y-intercept. The reason they must have different y-intercept is because if two lines have the same slope and the same y-intercept, they would be the same line. Let us take a look at some examples. In example 1, we are asked to find the slope of a line that is parallel to the line y equals negative 2/3 x plus 2. Notice how the given equation is in slope-intercept form, which is the form y equals mx plus b, where m is the slope and b is the y-intercept. Moreover, the given line has a slope of negative 2/3, which means the slope of the parallel line must also be negative 2/3. Let us look at a specific example of a line parallel to the given line. The blue line is the graph of y equals negative 2/3 x plus 2, while the red line is the graph of y equals negative 2/3 x minus 2. Notice how the slopes are the same and the y-intercepts are different. In example 2, we are asked to determine whether the lines y equals 2x minus 5 and y equals 2x plus 1 are parallel. Both equations are in slope-intercept form. Notice how both lines have a slope of 2. The y-intercept of the line y equals 2x minus 5 is negative 5, while the y-intercept of the line y equals 2x plus 1 is 1. The slopes are the same and the y-intercepts are different. Hence, the lines are parallel. Let's verify this graphically. The blue line is the graph of y equals 2x minus 5, while the red line is the graph of y equals 2x plus 1. Clearly, the two lines are indeed parallel. Now, let us talk about the slope of perpendicular lines. Perpendicular lines are two or more lines that intersect at a 90-degree angle or a right angle. Here is a graph of two perpendicular lines. Two non-vertical lines are perpendicular if the slope of one line is the negative reciprocal of the slope of the other. In symbols, if m1 is the slope of one line and m2 is the slope of the other line, m2 should be equal to the negative of 1 over m1. Let us take a look at some examples. In example 1, we are asked to find the slope of a line that is perpendicular to the line y equals negative 3x plus 2. Notice that the slope of the given line is negative 3. So, if a line is perpendicular to this line, the slope must be the negative reciprocal of negative 3. The slope of the line perpendicular to y equals negative 3x plus 2 is 1/3. Let us look at one specific example of a line that is perpendicular to the given line. The blue line is the graph of y equals negative 3x plus 2, while the red line is the graph of y equals 1/3 x minus 3. Notice how the slopes are negative reciprocals of one another. Moreover, the two lines intersect and form a 90-degree angle. In example 2, we are asked to determine whether the lines y equals 4x minus 6 and y equals negative 1/4 x plus 1 are parallel, perpendicular, or neither. Looking at the equation of the first line, notice how the slope m is equal to 4, and the y-intercept is equal to negative 6. For the second line, the slope is negative 1/4, and the y-intercept is equal to 1. The two slopes are different, so we know the lines are not parallel. If they are perpendicular, the slopes should be negative reciprocals of one another. Notice that 4 and negative 1/4 are negative reciprocals, and therefore the two lines are perpendicular. Let us look at the graph of the two lines. The blue line is the graph of y equals 4x minus 6, while the red line is the graph of y equals negative 1/4 x plus 1. Clearly, the two lines are indeed perpendicular.